In this video, with the help of valence bond theory, we are going to predict the hybridization, the geometry shape, and the magnetic behavior of some of the complexes. So for that you have to know some of the examples of weak ligands and strong ligands, and we have the types of hybridization and the geometry shape. Examples of weak ligands are NH3H2O, and those of strong ligands are CN, halogens, CO. Okay, now here if the hybridization is D2sp3, that one it involves the inner orbital, so the shape is octahedral. Okay, and then for the sp3d2 it is octahedral, and so on and so forth. So with the help of these, let us come to these two. Okay, so we are going to predict the hybridization and the geometry shape as well as the magnetic behavior of these two complexes. The first one, so you have to know the atomic number. What is the atomic number? Let's do for this one. Cr NH3 6 3 plus. The atomic number of chromium is what? 24, right? So what is the valence shell electronic configuration? It is, so chromium 24, it is argon 3d4 4s to 18 20 24. Okay, so this is the valence shell electronic configuration. So in the ground state, this is in the ground state, you have the 3d orbital and the 4s, 3d and the 4s, 1 2 3 4 5. So in the 3d orbital we have 4 electrons, 1 2 3 4, and here we have 2. Okay, this is in the ground state. But here, what is the oxidation state of chromium in this complex? X plus 6 into the charge carried by NH3 is 0, equated to plus 3. So the oxidation state of chromium is plus 3 in this complex. So in the plus 3 oxidation state, okay, in the plus 3 oxidation state, what will you have? When we say plus 3, it means you have to remove 3 electrons, 2 from the 4s and 1 from the 3d. So now 1 2 3. So let us write also here the 4p. Okay, 4p. So here we have 4p 0. This one is 3d4, or leave it like this also. So here also the 4p 0. Okay, so in the plus 3 oxidation state you are losing 3 electrons, 2 3. So in the 3d you will have only 1 2 3, since 3 electrons has been lost. Okay, so this is the electronic configuration in the plus 3 oxidation state. So now look here, how many hybrid orbitals are there? 1 2 3 4 5 6. These are the 6 D2, there are 2 D2 sp3, 6 D2 sp3 hybrid orbitals. Okay, empty 6 D2 sp3 hybrid orbitals. These empty 6 D2 sp3 hybrid orbitals are occupied by the 6 NH3 molecules. Hence, in this way, this complex is formed. So now, as I have told you, if the hybridization is D2 sp3, so from here, your hybridization is what? D2 sp3. Okay, here there will be no pairing of electrons because NH3 is a weak ligand. Since NH3 is a weak ligand, no pairing of electron will take place. So the hybridization here is D2sp3. If the hybridization is D2sp3, what is the geometry of the complex? It is octahedral. Okay, octahedral. And here, do we have unpaired electrons? Yes, we do have the unpaired electrons. So because of that, the magnetic behavior is paramagnetic. It is paramagnetic. It has 3 unpaired electrons. Okay, so in this way we find the hybridization, the geometry, and the magnetic behavior of the complex. So to be more clear, let us come to the second one. What is the atomic number of iron? 26. So the valence shell electronic configuration is this: 3d6, 4s, 2. So in the ground state we have the 3d, the 4s, and the 4p. So in the 3d orbital we have 6 electrons: 1, 2, 3, 4, 5, 6. And in the 4s we have 2 electrons. Here we have 4p, 0. So now we want to know the oxidation state of iron in this complex. So how to find? X plus 6 into the charge carried by Cn, it is -1, equated to -3. So from here you will get +3. So +3 is the oxidation state. So in the +3 oxidation state, what is the electronic configuration? +3 means you are removing 3 electrons. Okay, 2 electrons from the 4s and 1 electron from the 3d. 1, 2, 3, 1, 2, 3, 4, 5. 3d, 4s, and 4p. So you are removing 3 electrons, 2, 3. 1, 2, 3, 4, 5. Okay, yes. So look here, this one is a strong ligand. Since it is a strong ligand, it will cause these electrons to pair up. So what will happen? 1, 2, 3, 4, 5, 3d, 4s, 4s, and then we have the 4p. These two will pair up and we are left with one here. Because Cn is a strong ligand, that's why the electrons are pairing up. Okay, so here we have 1, 2, 3, 4, 5, 6. So there are 6 empty what hybridization? Again, D2sp3 hybrid orbitals. So these 6 empty D2sp3 hybrid orbitals are occupied by 6 Cn molecules in order for this to be formed. Okay, so from here, what is the hybridization? The hybridization is what? It is D2sp3. So if it is D2sp3, it is it involves the inner orbital, and the geometry of the complex is one of that FeCN6 3-, it is octahedral. And what about the magnetic behavior? There is one unpaired electron, so it is slightly what? Slightly paramagnetic, because there is one unpaired electron. Okay, so that's all.